Some idioms. So first question, of course, is what are idioms? Well, idioms are, no, I didn't specifically say anybody. So what are idioms? Idioms are usage patterns that may not be really as intuitive or obvious for somebody who are not native speakers of the language. If you really look at different languages, one of the biggest challenges in learning some of these languages is you might formally understand the language, you may understand the grammar, you may understand vocabulary, but often idioms trip you up because if you take the words and put the meanings together, it doesn't often make any sense at all. But idioms come from two things. Idiom comes from culture. Idioms come also from stories, some kind of a history behind them. Like, for example, when you hear the words like, it's raining cats and dogs, you kind of like, why would there be cats and dogs involved in the rain? Which doesn't really make any sense at all, right? So that kind of there's a connotation to it. In a similar way, when you look at programming languages, I was once writing a book on a particular programming language when I had the fortune of the author of the language review my book. And he came back and he said, no. You wouldn't, yes, that code is syntactically correct, but you would never want to write code like this. And then he showed me how you would want to really write this code. And I could have never caught that as somebody who is learning the language compared to the person who actually authored the language. And this happens a lot, so we want to really figure out idiomatic ways of doing things. But idiomatic styles can give us this advantage of writing code in a very expressive way, and sometimes even in an elegant way. So there are a few things we're going to look at here as idioms that we could use when programming in JavaScript. But the very first thing, though, is JavaScript does not have to suck. It doesn't have to look bad. We can actually write JavaScript in a way that it's elegant. But before I even talk about it, I want to mention two books which are, I think, really good in this area. The first book is JavaScript, The Good Parts. I would say is a must-read for anybody who wants to learn JavaScript and get better at it. Douglas Crockford's book. But the other book that also I found really fascinating was this book called JavaScript A Launch. And that also has some really wealth of ways in which you can actually twist and write JavaScript in a very elegant way. So I would definitely recommend that book as well as two things that I found really interesting as a read. So given this, let's talk a little bit about some of the things we can do. The first is we don't have to write methods and code that is very noisy. We can make it really fluent. Let's look at an example of this. So to understand what this means, let's say we are interested in using a class called mailer. Well, I'm going to use the good old JavaScript right now. So I'm going to say mailer is equal to a class, a function, but it's a class because we start with an case. That's a convention in JavaScript. So it's a mailer. And then in this case, I'm going to write a function. So let's say in this case, I want to have a function called, well, what do I want to define this function? Well, let's say this function is going to be called as from. And what I'm going to do in the from function is, I'm going to simply take an address, and then I'm going to simply present here output, let's say from. So that's all I'm going to start with. So how would I go about using this? I would say mailer is equal to new mailer. That's the first step. And then we would say mailer dot from. And where is this coming from? Maybe builder or build at, let's say, agiledeveloper.com. So that could be the from call. But in the same way, I could have other calls coming in. Like, for example, to this particular API, I could have a to, a subject, a body, and a send. So if you look at the to, all that the to is doing, let's say, is simply prints to, because we're just playing with the interface. Similarly, the subject takes a line, and all it's going to do is simply say subject. And then finally, I have a message, let's say body, and the body function is simply going to say body right here, but this is going to be message. And then finally, I'm going to have this send method. It doesn't take any arguments, but it could simply say, for example, sending, and then we could have that being printed. So typically in this case, mailer.from, and I may, where is to rather, and who is it sending the email to? And that could be my address right here. And then of course, the mailer usually wants to send this message, which has a very prompt, striking message. It says, your code sucks. And then it doesn't stop there. It has to tell me how it sucks. And so it may have details about it. And then finally, after configuring it, it might send out the email by calling a send. But if you look at this is a good example of a very verbose API, an API which is noisy also. And you keep saying mailer, mailer, mailer so many times. And if somebody does this to you in real life, you may probably strangle them, right? Because it's too many repetitive things. So this is an example of a very noisy interface. But we want to make it fluent. So what can we do to make this particular code fluent? Well, there are a few things we can do to make this code fluent. The first thing we can do is apply the so-called Cascade method pattern. So the Cascade method pattern says you can take an output of one call and cascade into another, and then you can take the output of that and cascade into yet another one, which is a really nice way to build things. Some of us may have called it as a builder pattern. And it's really nice because it removes that noise from the code. So to do this, what are we going to do? Well, first of all, I'm going to go back to these functions and say, when you're done with this, return the current object. So each one of these functions now begin to return the current object, except maybe send, because send is usually a terminal method. Then, of course, what am I going to do? Well, I can then go back to this code, and I can still use the new mailer, but I can remove all this noise and remove all these semicolons over here. And now, of course, we created a mailer. We called a from on it. We called a to on it. We call a subject and a body and a send, and we can nicely, so to say, stack them up. So we can remove these kinds of noise in the code. Well, while this gives us a little bit of a fluency, there is still one problem here. And the problem here is, you probably have seen this in quite a few different libraries. For example, if you use HTTP, you normally do a get and then an on error, and then you keep putting more methods on it. It's a very common pattern. In fact, if you look at something like, for example, set equals new set, which is part of ES6, I want to add an element to this set. I could say set.add, let's say Scott over here. Well, I could go ahead and print what's in the set and display the content on it. But if I want to come here and add another element, we could say add over here, and we could add Joe here. But in this case, we could also do the same thing by simply removing, and we could cascade it. So we don't have to be using set.add and set.add. So you can simply take the result of this add, and then you can cascade on it. So this becomes a very easy way of dealing with things. So these kinds of ideas we can use in our own libraries, in our own API. So when you're designing your own classes and your own functions, you can provide a nice way to cascade it, so the users of your own functions can benefit. And also when you look at third-party libraries that you're using, you can ask the question, how can we be more fluent in using them, and end up discovering some of these ways to do it. There is one good news and bad news. The good news is we removed the noise. We're not doing mailer, mailer, mailer anymore. But the bad news, though, is you as a user of this library had to create a mailer object. And one of the things to consider is those things called DSLs, domain-specific languages. One of the criteria of DSL is fluency. So when you provide a fluency, you want to make it as fluent and easy for somebody to use it. And from the usage point of view, this new mailer is a pure noise. You may argue, but I do need a context of an object, because I could have multiple objects of the same class in existence, and that's a fair point. But just because you need an object doesn't mean you have to force the object on the user of your class. The user of your class can still use an object without having to really create an object. This is where we have to rethink about how we design our APIs and say, how can I have a cake and as it eat it, so to say? How can I let them use an object, but how can I prevent them from having to create an object? Now, why is that a big deal? Because the minute they do new, they may be tempted to store into a variable. They might want to come back and use it later. Then you have to worry about it. Is this a variable they create and use it in one shot? Or is it something they can continue to reuse it? And that information is not very clear here. And unfortunately, we may have to go to documentation to illustrate that, which we don't want to do. So what we can do to avoid that problem is, we could turn this around a little bit. We could take this main, the send, and we could make the send a method on the mailer itself. So in other words, it becomes a static method. The minute it becomes a static method, we know that we don't need an object to call the method send. But we know we want to maintain a context for the from and the to and the such like that. But what we can do here is, we can tell the send method to take in a block of code. And then we can say, given this block of code, I can create a mailer right here, equal to new mailer, for example. And then I can call the block of code and pass the mailer to it. And then when you're done with the block of code, we could finish the sending. But the beauty of line number 20 is, it gives you the choice as a designer of this language, or the library rather. You can say, every time a send is called, I'm going to create a new object. You can also say, I don't want to create a new object. I want to just reuse an object that's already created. You could even say, I want to maintain a pool of objects. And every time you ask for a send, I might take one object from the pool. But the beauty is, send encapsulates that abstraction. Send says, it's not your business. You don't have to worry about it. Just call send, and I will manage that for you. So you're taking the burden off the hands of a user of your object, and you're saying, hey, you know what? Don't worry about it. New is an operation that you shouldn't be concerned with. You just sit back, relax. You say you want to send, I'll give you an object. You use the object, but don't you bother what the lifetime of this object is. It could be really short-lived, it could be long-lived, it could be from a pool, but it could be any combination, and guess what? I could even change it in the future, but you don't have to worry about it. So how do we do this? In this case, we just created the object, and then we pass it to the mailer. Then we're going to say mailer.send on the sending point of view, and you give me a mailer. And I'm going to go ahead and say mailer dot, and I'm going to call the from, the to, the body, everything except the send, and then close it at that point. So we just turned it around, if you will. So in this case, what we just did is, when you call send, an object is given to you. And all you're doing is, you're taking that object given to you and calling these methods you are interested in calling, and the rest of the code works exactly like the way it did before, except that you can change your strategy anytime as to how to deal with this object. So in other words, if somebody using your object don't have to be dealing with the new, you can relieve that burden from their shoulders in designing your libraries and APIs, and you can say, hey, just sit back, I'll give you an object, call it a context object. You can work with the context object, but on the other hand, you will not have to do new to create an object. So that is something you could do pretty effectively. This is a little bit of an extension of the Cascade method pattern. But we're going to see something very similar to what we just did. But this turned out to be one of my most favorite patterns of all times. This pattern has been for a good 40 years. This was used pretty heavily in Smalltalk. We kind of, it's kind of like rediscovering some of the things in the past. It's like your great uncles used to do something and you just figured out. And you're like, wow, did you know these people did? And an entire generation in between never knew about it. And you can come and discover what those folks did, right? And that's exactly what we're doing here. The previous 2 generations ago, if you will, did some of the things we kind of lost along the way because of the languages we were using in between. But languages like Smalltalk had some capabilities we are finally using more often now. And languages like Ruby have had these kind of features called execute around method pattern. So what does execute around method do? What does it mean? You often have a piece of code you want to execute. But around that piece of code, you normally want to do a pre-op and a post-op. So here's a way to think about it. Let's take a really silly example to work with it. So let's say for a minute, I want to rent a car. Well, what do you do to rent a car? So I'm going to go ahead and write a method called rent. And what does the rent method do? Well, rent usually has to do some things like clean up the car, right? So when you go rent a car, assuming it's a good car company, rental car company, what do? They clean it up. And then they give it to you. And then what happens? Well, hopefully, eventually, you return the car. Some of us do, others don't. But when you return the car, what do they do? They check for damages. More so for me than others. So, check damage. And they may do other things. But so those two are two different functions. But I might have a function called, drive to client site. So what does my drive to client site do? It's going to simply say, drive to work. And that's all I'm going to do. But I want to be able to drive to client work on a rental car. So what am I going to do? I'm going to call rent. I'm going to call drive to client site. And then I'm going to call return when I'm done. It's a very short trip that I'm taking. But I want to really have a nice weekend. So what do I want to do? I'm going to say drive to mountains. Right? Something Scott and I have said for a long time, but we never do this. So what am I going to do with this? We want to drive to the mountains, right? Well, this is going to be, of course, take a beautiful ride. So that's going to be simply take a nice ride. And in this case, how do I do this with the rental car? Well, I'm going to call rent. Then I'm going to drive to the mountains, as you would expect. And then when I'm done, hopefully, return the car. Well, of course, in this case, drive to the client side. Let's fix that. So that's going to be a function. So that's basically the code. But notice how much duplication you had in this code. You had to call rent several times. You had to call return car several times, which means you're violating the drive principle. You can also make mistakes. You may call them, you may forget to call them, you may call them in the wrong order, and a lot of things can go wrong. And if nothing else, it's tedious. You got to keep doing this over and over and over. But there's one thing very clear though. There is something you have to do before, and there's something you have to do after. You got to rent a car before you can drive it, for whatever reason, right? And then you do whatever you want to do with it. Hopefully they don't follow you where you are driving, right? That would be really, really weird, right? Hey, didn't I see you at the rental car center? Yeah, we're following you. That would be FBI, not rental car. And then when you return the car, obviously you return it and do whatever they want to do. Well, but I don't want to be duplicating this effort. So this is where the execute around method pattern comes in. How so? Let's give it a try. So I'm going to move this up here so we can kind of focus on this. So I'll come back to this in a minute. But instead, I'm going to grab these two guys for a second. We'll come back to it again. And I'm going to say over here, var rent a car. What does a rent a car do? It's a function, and I'm going to say drive. What in the world is this drive? This drive itself is a function. So this function says, I'm going to take a function from you. And in this case, I'm going to take these two functions we have here, the rent and the return car, and I'm going to move them as inside this particular function, as you can see. So those two are no longer available on the outside. But then what I'll do here is, I'll say rent, like we did before. I may even do a try and finally. This is not a bad idea, right? No matter what happens to the driver, you may want to recover your car. Not a bad strategy. So something we didn't even know before, right? We just kind of call this hodgepodge of functions, and when failure happens, we normally start with oops. Well, we don't want to be oopsing all over. We can just capture that logic. I'm going to say, I don't care what happened here, you better return the car, right? It's okay, even if you have a flat tire, you can return the car. That's a good idea. Tow it to the store. So in this case, of course, it's going to be return car. But in between, what am I going to do? In between these two, I'm going to take my drive function, and I'm going to call the drive function. So notice what rent-a-car does. Rent-a-car says, the key here is line numbers 18 through 23. It says I'm going to first call rent, then yield control to your method, when you're done with what you need to do, I'm going to come and finish up the post operation. So you're able to capture your policies. You're able to capture your functionality in one place. How does this help? Well, now I can say rent a car, and what do I pass here? Drive to client site. So you can see how it cleaned up the car with a spelling error there, and then it drives to work, and then it checks for damage. But the beauty is I can simply say rent a car and drive to the mountains. And I can reuse that very easily, and we know for sure the same set of pre and post ops are going to be executed because we captured them. A lot of libraries do this. You open a file, but you never have to close it. Because when you say open and you give a file name, and then you give a little lambda or closure to it, or an arrow function in JavaScript, and the function says, I'll do the open operation, I'll yield the file to you, you do your work, when you're done, we'll do the close for you. So A, you don't have to call close. B, you don't have to deal with forgetting to call close. C, you don't have to worry about exceptions and forgetting to call close in the exception. So a lot of those advantages come together. So this is one of my favorite patterns, like I said. I find it extremely useful. Places where I've used this are, I want to perform a transaction. At the end of a transaction, I want to commit, or I want to roll back. I would then say, wrap this up as create transaction, then I give it a body of code. The create transaction creates a transaction, calls my body of code, I do whatever I want to do, I return back, and the code says, let me sniff around and see what happened. If everything worked fine, I'll commit. If something went wrong, I will roll back, but I will register the logs for it. And the beauty of that is, I can just reuse that code any place I want to use it. That becomes a very consistent piece of code that can be maintained much more easily. So that's an example of the execute around method pattern that we could use very effectively. But I want to step back and talk about functions for a minute. This is one of the most beautiful features, in my opinion, in JavaScript. Scott talked about inheritance and how Java-like languages support inheritance, right? And that was a very clear decision they had to make. They don't want to just do everything that Java did. And for this, I would say this is probably the one feature I really, really like about JavaScript. JavaScript supports what is called prototypal inheritance. Prototypal inheritance is far superior than class-based inheritance. Class-based inheritance is static. Once you inherit from a class, you're stuck with it. On the other hand, a prototypal inheritance says you can your base class now, and a few moments from now, you can change it to a different base class. So which is very powerful. I mean, I've got wonderful parents. They're absolutely phenomenal. But you know what? They're very strict parents. And they will tell me, this is what you do, right? But I like them a lot. But I also know that Scott is a really good parent too. But he's also a fun parent. I know what his children have told about this, right? They know. So what I could do is, I could change this a little bit. I can have my mom and dad during the weekdays and get all the benefits they give me, the discipline they teach me, none of which will I get if dad was my dad. But just for the weekend, I'll say, Scott, would you adopt me? And so I can just for the weekend, starts 5 p.m. Friday, expires 5 p.m. Sunday, right? And I go back to my parents. Wouldn't that be fun? Not for him, but for me. Right? So we can work around where it can be really dynamic and change things. So how does this work? Well, you could say, hey, Venkat, can I have change for, 20 rupees? Oh, sure, I can give you change for 20 rupees. I can open my wallet and give it to you. But if you say, can I have change for $10, please? I don't have a reason to carry dollars in my wallet. But I'm not going to say no. I will reach over to my bank and get you change for dollars from here. So in other words, the bank is kind of like an extension to me. But in the case of JavaScript, a prototype has a prototype, has a prototype, has a prototype until there's no more prototype. And when you make a request, it keeps propagating the request until there are no more prototypes. So if I don't have something, it goes to my prototype. If the prototype doesn't have anything, it goes to the prototype's prototype and so on. And this can be a very powerful way to do things. This is one of the most charming features of JavaScript. It's kind of sad. The people who fear JavaScript, were scared way before they came to this part. You walk through a jungle, and then you discover Narnia. But a lot of people never got to the wardrobe. They got too scared before that, right? But if only they crossed over and got into Narnia, they would like, gosh, we want to live here, right? And then they would have the opinion, JavaScript rocks and JavaScript, right? As an example, or maybe not. But the point really is, this is where the real power is. So what does this really mean? What it really means is, let's take a quick example to see how this works. I'm going to say over here, I got Sam equals, and I'm going to say first is Sam. And I'm going to say over here, age is going to be, let's say 2. And in this case, we have a little object called Sam. But I'm going to say over here, let's write this as a var call work, and I'm going to pass an instance. And put a try, and put a catch, exception, and we will simply say no work. And here I'll say instance.work. So in this example, I'm going to take Sam, and I'm going to say call work, and pass Sam to it. So when I run this, what's going to happen? Well, in this case, of course, the object, Sam doesn't have a work method, it says no work. Well, that's definitely clear, right? But what I'm going to do here is, I'm going to say worker equals, and I'll define a work method. And what does this function do? It says working. So maybe Sam is a little too young for it. We'll make Sam 21. 2 is a little too early, aggressive. So what am I going to do now? I'm going to say call work and send Sam again. Oh, what's going to happen when I send Sam again? Still same, no work. But I'll go to Sam and say sam.proto is equal to, we'll say worker. Now notice what we just did. Sam, a second ago, did not have anything to do with work. Now you attached a prototype to Sam. And you said, Sam, look what you have. Now we all have read one design principle, right? Inheritance versus delegation. Which one is better? Delegation, right? Anytime, if you have a choice, if at all, prefer delegation over inheritance. What if inheritance becomes delegation? Wouldn't that be remarkable? And that's what prototype is. In prototypal inheritance, it's delegation, inheritance through delegation. In Java-like language, it's inheritance through inheritance. Whereas this is inheritance through delegation. So the proto is a special delegation. And the object says, when you call me, I'll go call that if I don't have it. So now when I run this code, notice it says working. God forbid, a few weeks goes by, and you know what happens to Sam? He gets the idea of being a manager. And manager says, work. And you know how this function goes? It is called play golf. And now Sam says, proto is equal to manager. Same call work, and pass Sam to it. Now what happens? That becomes play golf. I actually had a manager like this, by the way. After about a year, he said, heck, you guys are having way too much fun. I don't like this. And he turned himself into a worker again, than being a manager. We all loved him. And that can happen too. And you can kind of keep flipping this. Now imagine this. You could be in a production mode. You could depend on a delegate. You could be in test mode. You can depend on a completely different mocked up test object, right? So you can have the same exact object, but you're removing the guts around it. Very powerful way to do this. Either you can do this yourself, or you can use mocking libraries, which do this for you, becomes very effective. So this is the prototypal inheritance. But we can make use of this prototypal inheritance really nicely. For what? For a few little benefits. One of the things we're going to do here is, suppose I take a function called foo. And here is a function, and all this is going to do simply is, it says over here, foo called. Now, functions are objects too in JavaScript. If I print what foo is, notice it's a function, but it's an object. What is one thing you can do in objects? You can call methods on objects. So you can say foo.call, and you can call that method in two ways. You can call foo just as foo, or you can call foo.call. If this was taking an argument, you could send the argument 1 right here. But in this case, you can send a context object and the 1, if you will. So this gives you an ability to pass a few context objects also. But that means I could go ahead and say foo.f1. I want to call a function called f1. Clearly that doesn't work. It failed. Why? Because there is no such function called f1. But notice what I can do. I can take the function. What is function? That's the mother of all functions. Every function is that one. And he has something called a prototype. And I can go to that prototype and add a function called f1. And in here I can say f1 called. And I could simply say that f1 was called. And notice now when I call f1 on foo, all of a sudden every function has a function called f1 because we added f1 to the prototype. What does the function foo do? Foo says, I don't know what f1 is, but hang on, I'm not going to reject it yet. Let me go ask my prototype. And the prototype says, of course, I've got a function called f1, go for it. And so we just grabbed it from the prototype, right? Well, if we can do this, there are some really funny things we can do with this. One of them is currying. What is currying? I wish, but I'm not talking about that favorite Indian dish. Well, imagine if you want a celebrated life, wouldn't that be so cool? If your first name becomes a language name, if your middle name becomes a language name, if your last name becomes a language name and a concept name, wouldn't that be a way to live the life? Who am I talking about? Haskell, Brooks, Curry. Haskell, Brooks, Curry are 3 different languages. And the concept of currying, he didn't call it currying. If he did, that would be egoistic. He passed away, Haskell Curry passed away, and people who came after him said, this dude was really cool. Let's call this concept of currying. So currying essentially is you are caching certain parameters to functions so that you don't have to be calling it repeatedly. And that can be a very effective way to cache arguments, and you can send them. So how do you go about doing currying? How do you cache arguments? Let's give it a try. So let's say for a minute we have a function called log, and this function takes 3 things. It takes a level, it takes severity, it's a level, it takes a date, and it takes a message. And I want to call this method called log. So how do I call this method log? It's going to print level, plus it's going to print, let's say, the date, and plus it's going to print, let's say, the message. So those are the 3 things it's going to do. So I could say var today is equal to new date. I could say var level is equal to warning. Well, we can just pass that. So we can say log, and I could say warning, and I could say today, and we could say, for example, starting. Well, that's going to obviously print warning, and then the date, and then starting. But this is poor man's example. I'm going to say this is going to be running, and then finally I could say over here, stopping. But notice in this case, I had to repeatedly, so in this case I had to repeatedly call this function several times, right? But I don't want to be doing this several times. I don't want to be passing this over and over and over. I want to minimize the call. So what am I going to do? Var log warning today equals. Wouldn't that be nice? Then you say it's a warning, then you say today, and the only thing you have to pass is the message. So this part is working as we saw. So remove that for a second. What are we going to do? Log.curry. And what are we going to curry? The word warning and the object today. Then log warning today, and we could say starting right here. So we could say starting, and then we could also say log warning today and running, and we can say log warning today and stopping. right? At this point, if I ask Naresha, does Groovy support this? Yeah, he's like, cool, Groovy rocks, because curry is a function in Groovy, right? So absolutely, Groovy does this. What about JavaScript? Oh no, it doesn't know what curry is. But you know one thing about JavaScript, you never take no for an answer. You say, oh really? And you roll up your sleeves, here's how we do it. So we're going to curry up this. We're going to write curry in a way you can add curry to any function you want to use it on. Not just this log function. You can take any function. If I have a function called annoy Scott, and if there's a specific way I want to annoy him repeatedly, I can curry that on annoy Scott. And then I can just call that, right? And just change the variables I need to change after that. So how do I do this? Well, what I'm going to do, as you would expect, is I can first of all say function.prototype.curry equals. Now all of a sudden, curry is available in every single function, isn't it? Now what am I going to do in the curry function? In the curry function, I'm going to say function, and in this case, I'm going to receive some arguments. If I'm using the good old JavaScript, I will use what's called arguments. If I'm using more of a recent version of JavaScript, this would be curried parameters. It's up to you which one you want to use. This is a little bit more civilized. You can use a REST parameter, that's what it's called. If you're not using ES6, you don't have REST parameter, then you use arguments. You don't want to use arguments in ES6. You want to use the REST parameter. Using arguments is a little bit more painful, so I'll just use the REST here, but if you have to fall back, you can definitely do that. So what am I going to do in this case? I'm going to output curry called with, and I'm going to just say curried so we can look at it, and so we can see what it's going to send to us. So in this case, curry called with, notice that. Warning, date, it gave us that in the top. Don't worry about the error in the bottom. Look at the very top line. Curry was called with that. Why did it fail? Because we got a reference from it right here, and then we tried to call it. Poor thing, it failed because it was undefined. But we'll fix that. Well, notice this very carefully. We know that curry is a function now. What does curry do? It returns something on line number 16. What are you doing with that on line 18? You're calling it like it's a function. That tells you what? Curry is a function that returns a function. So all you wanted is to return a function. Okay, we can do that. Now what I can do then is I can go back here and I can say, well, return function. What is this function going to do? It is going to take some arguments up here. So we'll call it as given. That's going to be the given arguments. Whatever it is, you're going to give it to me at that point. So I'm going to return a function with the given arguments. Now, when will this be called? This will be called on line number 20 and 21 and 22. That's when this function will be called. And what's my job in this function? First of all, I need to know what the original function is. So constant original equals this. That's my original function, isn't it? The one that was originally given to me, the log function. So what am I going to do here? When you call this, I'm going to say return original. And what am I going to pass to it? The curried, and then I'm going to pass to it plus the given. Well, okay, I can't really just do a plus so easily, can I? Well, we can figure this out. So if I go back and bring up, let's say, node, we can easily see. The good news is the rest arguments are just arrays. So what I can do here is I can say node, and I could say array 1 is equal to 1 and 2. I can say array 2 equals 3 and 4. I can say A1 plus A2. That's not quite what I really meant. But JavaScript said, how about that? Like, thanks, JavaScript. That's not what I wanted. So how do I really add these two guys? A1 dot, can I say push? A2? And what did A1 do? Not quite, isn't it? But we could just concat it. A1 dot, well, okay, maybe I should reset A1. So let's A1 is that, A2 is that, and I can say A1 dot concat. Isn't that nice? A2. That's exactly what we wanted. Okay, we can do that. So let's go back to the code, and we can say read dot concat and the given. Well, wait a minute, that gives me an array of stuff. Well, okay then, I can then say dot apply null comma that value, and I can then pass it through. And notice how the code is working. So you can see how this returned a query on line 20, and the query is caching the two parameters warning and today, and the log for warning today says, thanks, I'll take warning and today, which is queried already, cached already, and I will concatenate it with the value you just give me, which is starting, and then I'll call the original function, which is log. So you can start really querying. It was not too hard at all. It's not that the language doesn't provide it. We can create this very easily in a library, right? And so we can start querying things very effectively as well, pretty nicely. Now, you can also honor this by passing the this, but I'll skip that part right now. Then comes along yet another interesting thing we could do with this. This is a slightly different concept. So to understand this, let's take a little example. Can I bother you with a quiz? You can sit there and answer comfortably. So, what is 2 plus 7? 2 plus 7 is 12? He's buggy. I'm not asking you to function like JavaScript. So what is 2 plus 7? 9. You're awake now. All right, I know, put you on the spot. Okay, 2 plus 7 is 9. I mean, for a minute, I'm like, boy, inflation is very high. Okay, so 2 plus 7 is 9. Are you going to change your answer if I ask you again? No, okay, so it doesn't matter how many times I ask you, right? But why are you not going to change your answer? Why are you not going to change your answer? No matter how many times I ask. That's a pure function. A pure function will give you exactly the same result no matter how many times you ask. That's the beauty of a pure function, right? Great. So one more question. What is 121 plus 325? Now I put you on the spot. 445? 446? Are you sure? Pretty much. Can somebody verify this? All right. So one final question for you. What is 121 plus 325? Did you notice a difference? Hey, it took forever the last time. This time he snapped back. In fact, he even gestured it. It's kind of obvious now. Wow, how did you become so smart? What did he do? He cached it. Does everyone here understand the word cached? That's why we don't use it. In computer science, you never use words everybody understands. We'll call this memorization because it sounds so cool. What is memorization? And we'll cache it. So in other words, if you know your function is pure, you can cache it. You can memorize it. What's the benefit? What was the benefit in memorizing? Speed. He snapped back with the answer, right? Purely functional languages do this internally. I was blown away by this with Haskell, by the way. I was using Haskell, and I was still learning at the time, and I'm still learning, nevertheless. And I called a function. It took a good 15 seconds to run because I had a lot of intensive operations. I said, okay, thanks. And for some reason, I said, call it again. Boom. I'm like, whoa, how did you give me the result so fast? I quit the entire program, restarted it. First time I asked, 15 seconds. Second time I asked, bam. That's when I discovered, and they don't call it memorization, they call it thunks. They literally store the thunks of operations. So when a function is pure, you can do it. Well, let's take a look at an example real quick and see how this works. So in this case, I'm going to take a little example here. I'm going to write a function called fib. What does fib do? It's a function that takes a number. And it says if number is less than 2, return 1. Otherwise, return fib of n minus 1, number minus 1, plus fib of number minus 2. Very simple, right? So what do I want to do? I want to call fib of 1. Well, clearly that's a 1, right? So I'm going to print out the fib of 1. So print it, 1. I'm going to try fib of 2. That's a 2. Fib of 3. That's a 3. Fib of 4. That's a 4. Fib of 5. That's 8. So far so good. Fib of 15. Okay, cool. Fib of 25. Hey, that was not bad at all. Fib of 35. 40. Did you notice a little delay? 41. Waiting. 42. Is it taking longer? 45. So what's happening? This is an example of an exponential function, isn't it? Even a slightest increase in the number can result in the response taking a lot of time. We'll try only one more thing and we'll be moving forward. Got it. You're like, no, please don't. We want to go home tonight, right? I was looking at this. I was reading Hitchhiker's Guide to the Galaxy with my children. And in that, they're doing a computing for the meaning of life. And they've been waiting for several million years. This was a great opportunity to stop reading and talk about exponential complexity and NP-hard problem to children. This is one of the reasons both of my children said they will never, ever become programmers in their lives. So just a moral for you. If you have young children, don't do this. Because that's what I did to my children. And they said, Dad, this profession ends with you in our hierarchy. I'm the last Subramaniam, who is the programmer. The last programmer, right? So, but anyway, it was fun. We kind of talk these geeky stuffs all the time, which is fun for the children to explore. But that's really what's happening, right? Because it's exponential. You call fib of 45, what does it do? Compute for 44 and 43. To compute 44, what does it do? Recompute 43 and 42. So it computes and recomputes and recomputes. An example of where we can use memorization, isn't it? So what do I want to do? What I want to do is come to the fib function dot memorize. Wouldn't that be cool? He's laughing. You know why he's laughing? Why are you laughing? Because Groovy does this already. Why are you sitting here then? Groovy does this already. So we can definitely do this. This is one of the benefits of being polyglot. You can bring ideas from one language into other languages, right? And Groovy does this. Groovy does this very differently than other languages like Haskell do. How does Groovy do this? Groovy says, aha, we can take a closure and we can create another closure which will do the memorization. So we can do that pretty effectively. But of course, this is JavaScript, right? So when I go run this, it says, what are you talking about? Call memorize. Oh, JavaScript, don't worry about it. We'll help you. So what am I going to do? Function.prototype again. Dot memorize. Now every function in the world can be memorized. Isn't that cool? No, not really cool. Don't do this unless you really mean it. So what do? I create a memorize function. And what do I want to do in this memorize function? Return another function, of course. So constant original is equal to this. Save it away. Much like what we did on the other side. But of course, when you call memorize, what am I going to do? Return a memorize function. And then I'm going to return a function that you're going to call. When you call the function, what do? You normally pass a piece of data, like this one, 45. So this is going to be the values, right? Values or inputs, whatever you want to call it. In this example, I'll chicken out. I'll just do a one input. Let's say input. What am I going to do with this input? When you give me this input, the first thing I'll do is I will take that into a key. So I'm going to call a function called generate key. Actually, I'll just write it here. So I'm going to say JSON.stringify And I'm going to give arguments. So in fact, I'm going to just turn this into inputs. That way this becomes inputs. So I will do the right thing. So we'll just stringify that and say, give me a little JSON object. This is going to be a key. So constant key is equal to. Now that I have a key, what I can do is I can create a memoized cache. So I can say over here, let cache is equal to, and I can create a little memoized. I could use a map, because now JavaScript has a map. I could do that too. If you're an old version of JavaScript, you can just throw a JSON object there. That's perfectly fine. Then what am I going to do? I'm going to say, hey, you, if the cache dot has the key. Well, if the cache doesn't have the key, let's put an exclamation in front of it. If the cache has no key, what do I want to do? I want to call the original function, right? Dot apply, and what am I going to pass to it? The inputs. And this is going to give me the data, cache.put, key, comma, that value. Does it make sense? So you're saying, when you call me, if my cache doesn't have this key, I'm going to go do the work. Dump the result into the cache. And when I get out, all I'm going to do here is return cache dot and get the value for the key. So obviously, to do things, you got to do a lot better than this. But this opens a door for what you could potentially do, right? So you can say, I'm going to memoize this. So I'm going to create the cache. When you call me, I'm going to grab that as a key. I'm going to check if the key is in the cache. If it is, I'll return it. If not, I will calculate it, insert it, and return it. So is this going to work? We'll find out. So let's go back and say for a value of 2 to begin with. Oh, put, it's add or set? Set. So set, thank you. So in this case, let's try a 25. That's working. Should I run it? I'll run it. But I got to promise to be here until it finishes. Right? So that was a snap, wasn't it? Because of memoization. In fact, you could do this competition. Tell your friend to do this. And while they're still running this, you can go eat their lunch. Right? So memorization is pretty wicked. Why? Because it took the problem, which is exponential, and converted it into a linear execution. There is a special name for these kinds of problems, where you do recursion and then you optimize. This is another thing I love about our field. This kind of algorithm is called dynamic programming. It is neither dynamic nor programming. That's what it's so awesome. It is an algorithmic technique after all. And a lot of different algorithms use this very powerful modeling, and that's what we are seeing here. We just injected a memoize function. So essentially, that's what we did here, is to benefit from that by calling the memoize. I want to show you one more thing that's been around in Java for a very long time, but it's been lost for a good reason. Suppose you have some numbers, and the numbers I have are 1, 2, 3, 4, 5, 6. Let's just take these numbers. I want to find, let's say, find the total of double of even numbers. You can do this in the imperative style. You can say var result is equal to 0. You can output the result when you're done. But what am I going to do here? For var I equal to 0, I less than numbers dot length I plus plus. Then you could say over here, if, so let me make it a little easier. Var number is equal to numbers square bracket I to store it into a variable. Then I'm going to say if number mod 2 is equal to 0, then I can say result is plus equal to number times 2. And we could write the code like this. But it turns out that's very verbose. But strangely enough, what I'm going to show you now has been in JavaScript from day one. But why didn't we use it? This is where most of us who use JavaScript also used other languages, like Java, C#, C++. What do these languages do? Every one of them gave you imperative style of programming. What did JavaScript do? It said, you could do this or you could do this. And you're like, wait, if I'm doing it this here, and if I'm going to do something completely different there, my brain begins to hurt. My fingers don't type. I type it this way here, I type it the other way here. What I type here doesn't work. You know what? I'm going to just be consistent. Consistency is good, but consistency also can take us backward like it did in this case. So we've had a power for a good 20 years that just went mostly unnoticed. So what I can do here is, I can do the following, right? I can say, instead of doing it this way, I can say, well, output and numbers dot, and I'll filter. We'll take baby steps. Given an element, element mod 2 is equal to 0. So in this case, I'm asking only for even numbers. Then I can say dot map. Given an element, give me an element times 2, double of the even numbers. Finally, I can say dot reduce. Given a total and an element, return total plus the element. So you can write code in a very elegant manner. This has been around for a very long time. We still chose the verbose way than this way. Why? Because the other part of the world did this. And so we said, it's just easy. Right? Well, okay, it's concise, but it could be a little less noisy, right? Well, actually, in the old JavaScript, what you would have done is you would have said, function E, return E times 2, or E mod 2, right, is equal to 0. This is how you would have written in the traditional JavaScript, which is a bit noisy. You would have written this in the traditional JavaScript as function E, and then return E times 2. And then likewise, in this case, you would have said function total, and then you would have said return total plus E. And you could have written it like this, with a little bit more verbosity in this, right? So this is going to be ending the return for the function. So this is the function ending. This is the reduce ending. That's the log ending. That's a little verbose. But rather than writing it so verbose, there are two options. If you're still using old JavaScript, you could roll these into a separate method. You could have said is even is equal to function. Given an element, return element times mod 2 is equal to 0, right? You could have done this. Similarly, you could have said double equals function E. And then you could have said return and element times 2. And then finally, you could have said var add 2 equals function a comma b, return a plus b. Then you could have said, rather than working so hard, you could have said output numbers dot filter is even, dot map double, dot reduce add 2. So you could do this too. You can still do this in the old JavaScript. But if you're in ES6, you can write the same thing as the numbers. So numbers dot filter, like I showed you, using the so-called arrow functions or lambdas. E mod 2 is equal to 0. So you can choose whichever approach makes sense for you. Dot map given an element, element times 2. And then finally dot reduce, and then you can say total comma element, and then return total plus element. So it removes some of the noise, some of the ceremony, and some of the extra methods. And you can write it that way also. But the beauty is that has been around for a long time. It just became a little bit more fluent, but we can make use of that also. So as we write JavaScript, if we pause and think about the code we write, we can make it a little bit more fluent along the way, and we can reduce the noise as well. So we looked at a few different idioms. We're still writing JavaScript, but we can bend things a few and write things in a little bit more elegant way, make use of certain features that are not in the language, but we can easily create them and make use of them. So that makes writing JavaScript a little bit more joy as well as we begin to do that. Hope that was useful. Thank you.